going beyond ethane, let's add a carbon to it. Let's go to propane. Propane will be very similar to ethane, except the torsional strain will be slightly larger because instead of having one of the HH interactions, we now have an H to a CH3 interaction. The other ones are still the same, but if I have eclipsed propane, now I have a hydrogen trying to share space with a larger methyl group. Okay? But otherwise, it's going to look very similar. If I look at their 3D models for propane here, if I want to look down carbon 2 and carbon 3 with the methyl group in the front there, notice we still have our more stable conformation as this staggered conformation. Okay? If I were to rotate about that bond a little bit, now we would have a CH3 covering up a hydrogen, which would be a little less stable, but still, the graph of rotation versus energy would look exactly the same as in ethane, where anytime we were eclipsed, it would be high energy, and anytime we were staggered, it would be low energy. Butane, though, is a little bit complicated yet, because not all the staggered conformations are the same, and not all the eclipsed conformations are the same. Here's sort of a representation, a picture of a butane molecule with a Newman projection next to it. Notice in our Newman projection, we're always looking down the carbon 2, carbon 3 bond. So the middle two carbons. On this Newman projection here, I have the front carbon going straight up and the back carbon going straight down. So here's a three-dimensional model that represents that same Newman projection that I had. Okay? Look at it from the side. We can see we're looking down the carbon 2, carbon 3 bond, but the front carbon has a CH3 group going up. The back carbon has a CH3 group going down. This is the most stable conformation of butane. It is staggered just like the ethane one was because everything sort of has its own place, but it's a special kind of staggered representation called anti, where this methyl group on the front and that methyl group on the back are as far apart from each other as they can possibly be. So that's the anti conformation. If I rotate one of these carbons by 60 degrees, I now have an eclipsed conformation where instead of just having one CH3H interaction in propane, I now have two CH3H interactions. So this is obviously an unfavorable interaction because the groups are right on top of each other. They're covering each other up. It's called eclipse. So that's going to be unfavorable. As we rotate a little more, we end up with another staggered conformation, similar to the first one we started with, except now I have two methyl groups that are next to each other. So everything still sort of has its own place, but there's going to be an additional strain called steric strain. That's where large groups are repelled because they're a little bit too close to each other. So different from torsional strain, because torsional strain was specific to when they were eclipsed in the Newman projections. Here I have things that are staggered, so everything has its own place, except these large methyl groups are still just a little bit too close to each other. You can see that these hydrogens, looking at it from the side, are really approaching each other. Their electron clouds are going to start to repel. So we sort of draw these two parentheses when there are two groups that are way too close to each other. So this conformation has a special name. It's called gauche, Gauche. If we look at this model right here, we see that things are staggered, so nothing is directly in front of each other, but these two hydrogens right here, just a little bit closer than they would like to be. Right there. So gauche is not that bad. Everything still has its own place, but it's not as good as the best one, when they were both all the way apart. Okay? When one methyl group was totally opposite each other. That was the best arrangement that they could have. So gauche is not bad, but it's sort of the second best of the arrangements. Okay? So if I rotate one more beyond that, I end up with a conformation that's called totally eclipsed. Okay? So totally eclipsed, where I have now two methyl groups that want to be right in front of each other, and this is going to be a major problem. Methyl groups are very large, much larger than the hydrogens. So to have two of them right in front of each other in the structure will be very unfavorable. So this totally eclipsed is the worst of the arrangements. Anti is the best. Okay. Both of the eclipsed ones are going to be bad, but this totally eclipsed one, right? This totally eclipsed one is the worst. Partially eclipsed, right? Where everything is still eclipsed, but the methyl groups are not in the same positions, right? That's second worst. Gauche is second best, because it's still staggered, but those methyl groups are a little closer to each other than they would completely like to be. So there's that steric strain I was talking about. Steric strain is important in both the gauche and the totally eclipsed. Conformations of butane. So take a look here. Anti is the best because the methyl groups are all the way far apart. Okay. We do one eclipsed that's pretty poor because things are still eclipsed with each other. Right, one thing right in front of each other. Rotate a little more, we get gauche, which is fine, but not as good as the best one because of that steric strain. Then rotate a little more to totally eclipsed, which is the worst, because not only do we have steric strain, but we have steric and torsional. Strain. Rotate the other way, we get the other gauche. Not so bad, but not the best. Rotate again, we get an eclipsed that's bad, but not the worst. And then finally, we're back to anti. So if I were to rank these, where anti was the lowest in energy and totally eclipsed was the highest in energy, we'd be at positions 1, 3, 2, and 4 as we're going through those. Both of the eclipsed ones are worse than both of the staggered ones, but the anti, the one where we've got methyl groups totally opposite each other, is best. The eclipsed one where the methyl groups are right together is the worst one. So to finish up on this, let's take a look at this animation. Again, linked to on that webpage, that shows you a butane molecule rotating about its center carbon-carbon bond. And watch it. There's the lowest energy. There's the highest energy. There's the lowest energy when they're across. Here's the highest energy when they're together. So you can stop it at all these places. They use a different word, but use what we said, ch3 eclipsed, okay, as the highest energy that's possible there. Anti is the best when they're 180 degrees apart. Here's gauche, which is good, but not the best. So I think that's about it. Please familiarize yourself with these terms as you're building your models. Make sure you can be looking at a butane from the side, rotating it all the way, asking yourself whether this one is better than or worse than the one that it came from. Understanding that the highest energy conformation of butane is this totally eclipsed conformation, because first of all, there is steric strain, because those two large groups are trying to occupy the same space, plus there's torsional strain. Where we have groups that are eclipsing each other. The hydrogens show no steric strain because they're not large enough to actually occupy the same space, but still, anytime there are bonds that are directly eclipsing each other, that's called torsional strain. So that's it for our chapter. Make sure to practice the problems, get your models, get those exercises done in the POGIL workbook. Go through the nomenclature worksheet in that POGIL workbook. That'll give you plenty of practice naming alkanes, just like we did in this chapter. So that's it.